The third type of question that we are trying to answer in biostatistics is a question of hypothesis. So you're trying to test an hypothesis. So we call it hypothesis testing. Now, an hypothesis is just an idea that someone has given, and it's not every idea that is correct. Some ideas have to be proven against, others have to be supported. So, a question of hypothesis testing, and we talked about what an hypothesis is. We also talked about the null hypothesis and the alternative hypothesis. So hypothesis, you are trying to compare two methods, right? The method that is already there, and then the one probably that you're trying to find out, and then you want to see if there is a significant difference between the two methods. So if there is no significant difference, it means that your hypothesis is actually fine. N- Or maybe the hypothesis that is already there is fine because there is no significant difference between two quantities or variables that we're trying to measure. These the three types of questions. Question number one, which is descriptive in nature, and question number one, descriptive. Question two, effect estimation. Question three, hypothesis estimation. When you talk about statistics, you can therefore classify biostatistics into too many categories. Classification of biostatistics. So you are going to classify biostatistics into descriptive biostatistics, and the second category is going to be inferential. Okay, now the descriptive biostatistics, the question that you are trying to answer is question one. So this one answers the descriptive question. And then for inferential, to make an inference is to make a conclusion or a generalization. You have found out that people between 20 years and 40 years in Zambia, let's say their mean blood pressure is this. So you can now make a general conclusion to say everyone, maybe that's because for your study you didn't use everyone in Zambia. Probably you just picked a certain population or a certain sample. And then from that sample now you can make a generalization that is an inference. So inferential statistics answers the question of effect and hypothesis testing. So this one answers the question of effect. Number one, effect, and then number two, hypothesis testing. Okay, so those are the major divisions of biostatistics. Now that we have understood this, because biostatistics is a science that deals with statistics, we're interested in calculations in this course. So there are two terms that you have to understand. We have got a population, and then we have got a sample. When you are studying, it is very hard for you to deal with the actual population because, yeah, let's for example in Zambia we've got 18 million people, and let's say want to find out how many people in Zambia are affected, or what percentage of people in Zambia are affected by a certain disease. It can be very hard for you to do that. So what do you do in that case? You are going to just get part of the population, and that becomes a sample. So the sample should be in such a way that it should be representative of the population. Let's say for example you want to find out the if the pass rate, or how hard, let's say, pathology or microbiology is to the med 3 class. If you want to really tell how hard the pathology is to the med 3 class, you will not go and pick two students, because the thing is that you can actually end up just picking the best student or the least student. So the information that they are going to give you will not be representative of the entire population. So the people that you get, that is just a sample. So the best, if you want to make sure that the sample that you get is going to represent your population, you need to get a random sample. A random sample. A random sample is good in such a way that it is going to help you to get something that will be fully representative of the population. So, some things that you need to pay attention to. For a population, we have got something that we call parameter. And when we come to a sample, these parameters, we are going to say it is statistics. 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 Some other things that you have to know is, let's say you count the number of people in a population. We call that as a census. You can even forget the spelling of census. Okay, that's a census. But when you count the number of people, but this is not a population, it's just a sample. Call that as a survey. Okay. And again, when you are working with statistics, there are some terms that you'll be dealing with. For example, if I'm talking about standard deviation or variance of a population and the standard deviation of the sample, it's going to be different. In that, for one of these, we are going to be using Greek letters. For the other one, we are going to be using uh, English letters. Okay. So again, as we said, we have got sample. Sample is a subset of a population. Survey is collecting data from a sample. Census is collecting data from a population. Okay. And then we have got different parameters that we are going to be using. But please take note that for statistics, statistics is a numerical measurement describing the characteristics of a sample. And in statistics, when you're dealing with a sample, we use English letters. And then for a parameter, it's a numerical measurement that is describing the characteristics of a population, and we use Greek letters. Let's say, for example, I'm talking about variancy. Variancy is because for population we use Greek letters, we are going to use sigma squared, but for a sample, we are going to use s squared. That's variancy. And then for the mean, for the population, we are going to use the mean, we use nu. That's a symbol. And then for the sample, we are going to use x with a bar on top. That's the mean. So just make sure that you take note of this. Okay. So now when you are trying to gather information, you get a sample, and then from that sample, you now want to find out, let's say, the effect of a certain disease or whatever that you're trying to find out. You use different sampling techniques because the population or the sample that you're trying to study, you don't just say, okay, you come, I ask you some questions. If you do that, it might not be that representative. So you have got what we call sampling techniques. If you want to make sure that your sampling is good enough, there are sampling techniques that you use. And we have got different types of sampling techniques. And we divide them into two main categories. We have got number one, what we call probability sampling. And then the second one is known as non-probability sampling. So please, if you have got any question up to this point, feel free to be able to ask, all right? So we have got probability sampling, and then we have got non-probability sampling. Probability sampling is also known as random sampling. So this is it. So if we're talking about probability sampling, what do we mean? So in a probability sampling, each member of the population has an equal chance of being selected. And it's important for you to take note. Each member has an equal chance of being selected. So you are not specific to say, okay, this is who I'm going to pick, because you don't, even you, the one who is carrying out the research, don't know who you are going to pick. Okay. Now, in probability sampling, again, you have got different types that we have to know. Number one, so let's divide them. You have got what we call simple random sampling, simple random. Number two, we have got what we call stratified sampling. Number three, we have what we call cluster sampling. And then number four, we have got systemic sampling. Okay, simple random, stratified, clustered, and systemic. And then for the non-probability sampling, we can also divide it. It also divided into what we call convenient sampling or convenient sampling. The second one, we have got purposive sampling or purposive sampling. And then number three, we are going to have what we call quarter sampling. And then number four, we have got what we call snowball. So for you to understand, let's start with a simple random. I'm not going to write anything. Please just get to follow me through. So simple random, you have got your population or your, let's say your sample in this case, because we don't normally deal with a population. From that sample, you are simply picking people. And for each person that you are trying to pick in probability sampling, specifically simple random, each member is going to have an equal chance of being picked. So it's basically the definition that I put there. And then for stratified sampling, the population is going to be divided. We call it stratified. You know, stratified is, you have, remember the epithelium, stratified columnar, stratified squamous. You have got like layers. So in stratified this sampling, the population is divided into subgroups, which we call strata. Okay, population is divided into subgroups, which we call strata. And then after you divide into subgroups, in those subgroups might be sharing some common characteristics or not. And then now using those subgroups, you now use this simple random sampling. Let's say, for example, you have got a class of 100 students. You get this class of 100 students, you put them into groups, let's say of 20, 20, 20, 20. And then you go in that group where there are 20 people, you now use simple random sampling. Let's say you start counting. One, two, okay. Maybe let's say you write numbers on a paper. You ask all of them to pick. And then you say, all those that have got ones, come to the front. You are the ones that we are going to use in this study. So that is simple random. But then remember, initially you had put them in groups. So because of those groups which you call strata, it becomes stratified sampling. All right. And then for the cluster sampling, here the population is going to be divided into what we call clusters. And then after that, random samples of clusters are going to be selected. It's not too different from the one that is on top, the stratified, a bit similar, because we're also putting them in clusters, and then now you later on get to choose people from there using the simple random sampling. Okay. And then for The systemic sampling, this one, what you do is that you are going to get samples at a regular interval. For example, every after, you'll be counting 1, 2, 3, 4, 5. The fifth person will be part of your study. The next 1, 2, 3, 4, 5, the fifth person is part of your study. And then the next, just like that. Do we have any questions up to this end? If it's okay, please just react. Just show me any emoji so that I see that we are good. Okay. So for cluster, you have got people, part of your sample or your study. You put them into these groups which are calling clusters. Let's just try to differentiate cluster from stratified, probably. In stratified, you are looking at characteristics within the population. Let's say people that have got similar features, you get the males, you put them in one group. Okay, or let's say people that have got at least a certain feature that is common. Okay, you put them into groups. Let's say based on characteristics, a certain characteristic. Maybe these are all smokers. Okay, let's put them together, and then after we put them together, and then those that drink, we put them together, and then those that do this, we put them together, and then in those small groups, you now use the simple random sampling to pick people from there. That is stratified. You are using certain characteristics that are common to put people into stratas or groups. And then in class study, you get to pick people based on geographical or natural grouping. For example, males be here, females be here, and then for the males, you use simple random sampling. For females, you also use simple random sampling to pick some people out of them. Or you can use geographical representation. Those that stay in this area, you are going to be together. Those from this area, you're going to be together. And then now using those clusters, you now use simple random sampling to pick people from there. Does that make sense now? All right, great. For systemic, remember you are following a certain system, so you are counting, let's say, 1 up to 5, we pick people. 1 up to 5, you pick people just like that. Okay. So that is it on the probability sampling. And then for the non-probability, the first one is convenience sampling. Even from the word conveniency, your population study, the people that you are getting to participate in your study are the people that are within your conveniency. Okay? Samples are selected based on the ease of accessibility. How easy can you find them? For example, your lecturer wants to do a study at UNZA. Why should I struggle? These are my students. Okay, you guys, I'm going to get you. You are going to be part of my study so that I find out of, let's say, what is going on at Ridgeway campus, the complaints of students at Ridgeway campus. So that is conveniency, looking at how easy you can access people that are going to participate in your study. For purposive sampling, even from the word purposeful, you are getting samples based on a specific criteria or characteristic. Let's say, for example, I want to find out the effect of, let's say, uh, drinking on passing. You will not get people that don't drink. So you specifically go and get people that drink. You look at a certain feature or certain characteristics purposefully, right? That is purposive sampling. And then for quota sampling, here samples are selected to meet specific quotas or criteria. For example, you want to get people that fall within a certain age or a certain gender, okay, to meet a certain criteria. And then now you study them. So that is the quota sampling. It's not probability, because probability, you don't know the people that you are going to be dealing with. And then for snowball, here what you do is there is already an existing study participant, and then you know the way a snowball behaves. let's say you are on there is a mountain here, that, and then there is snow, and then there's just going to be a kama small snow here. As this kama small snow starts falling, it will be becoming bigger. Okay, to be becoming bigger. So here, let's say you get one person, they have got a certain feature, and then you tell them, if you know anyone else that can be interested in this study that has got this feature, please bring them also to be part of this study. They bring their friends, and then that other one can also bring their friend. At the end, the study population is becoming bigger and bigger. That is what we call a snowball. Okay, I hope that is okay. Now, for the probability sampling or the random sampling, we can do random sampling without replacement or random sampling with replacement. Let's talk about what's the difference. Random sampling, number one, with replacement, and then number two, without replacement. So for those that we are getting with replacement, let's say for example, you have got a bucket, and that bucket contains balls. Okay, you have got a comma bucket which contains, let's say, six green balls and then four blue balls. What is the probability of picking a green ball? So the probability of picking green as the first ball is going to be 6 out of 10. Okay, now if you got a green ball, right, and then you had to replace that green ball, what is the probability of picking the next green ball? So it's still going to be 6 out of 10. Why? Because we had to replace the green ball that we picked, we put it back and then we picked again. So here the total is going to be, you get to multiply these two. And then now for without replacement, let's say you have got the same six green balls and four blue ones. Sorry, just a moment. Okay, so let's say you have got these people, or these balls. Six of them are green, four of them are blue. For the first pick, the first ball that you pick is, let's say, white. So the probability is going to be, or let me say blue, I don't even have white here, it's going to be 4 out of 10. But remember, this ball was not replaced. So since it was not replaced, the next pick is going to be, if you pick another blue ball, the next pick will now be 3 out of the total, will now be 9. Because remember, at the beginning we picked something that was blue. So meaning that the blue, instead of now being 4, they are now 3. And the total has reduced from 10 to being 9. Okay, so that is how you deal with the picking without replacement. I hope that's okay. Now let's dive. Please, do we have any question before we dive into some calculations on statistics? Any questions? If it's okay, let me see some reactions to signal that we are okay with what we've done so far. Okay, so we have got a bucket that contains these six green balls and four blue balls, right? From these, we do it at random. You've closed your eyes, you've shaked the bucket, and then you pick a ball. The probability that the ball that you have picked for the first time is going to be 4 out of 10, isn't it? Because that's how many you have. But since you didn't put back that ball, okay, if the first time the probability of picking a blue ball was 4 out of 10 and you've picked a blue ball, the probability of picking another blue ball is going to be, because I've removed one blue ball already, the total has now, so we now have 6 green and 4 and 3 blue. Okay, so the probability of picking another blue ball will now be 3, isn't it? And the total is 6 plus 3, which is a 9. I don't know if that's okay. Okay, so there's actually a way in which we can do this. If we want to be a bit of detailed, we can write it as the first pick, the second pick. So we can do this. We can say green and blue, okay, with replacement. So for the first time, the probability of picking a green ball is going to be 6 out of 10. Picking a blue ball is going to be 4 out of 10. This is for the first pick. If there's no replacement, the second pick, if we, for the first, the one on top, we are imagining we picked a green ball. So meaning that for the second time, we've reduced the green balls. They are no longer 6. They'll now be 5. So if I want to pick another green ball, it will be 5 out of 9. But for the blue ones, if we picked for the first time something that was green, the blue ones are still 4, but the total is still 9. But if in the first pick we had picked something that was green, sorry, we had picked something that was blue, it means that now the blue ones have reduced from being 4, they are now 3. The total is now 9. But remember, for the second part here, we are saying that we had picked a blue one, so meaning that the green ones are still 6 out of 9. Okay, so if asked, you find the probability of in the first pick you pick something that is green and then you pick something that is blue. So green and then blue, you are going to say G, and then remember this one which is down is for blue. So the probability for that one is going to be 6 out of 10 times 4 out of 9. If the question said find the probability of picking a green and blue ball, it is not specified which one is first. So green and blue ball, you get, this is green, this is blue, this is blue, this is green. So the probability of picking a green and a blue ball, you can either pick a green and then blue, or we pick blue and then green. So we're going to multiply 6 out of 10 by 4 out of 9, and then you are going to add the answer that you find. You multiply 4 out of 10 by 6 out of 9. So if they said find the probability that all the balls that were picked were of the same color, in that case, what we are going to do is same color means green and another green, and then blue and another blue. So it will be 6 out of 10 times 5 out of 9 plus 4 out of 10 times 3 out of 9. If they said find the probability of picking first a blue ball and then a green ball, so it will be 4 out of 10 times 3 out of 4, or actually this 3 is for another blue, so it will be 4 out of 10 times 6 out of 9. So that is how you'd be working out these guys. Okay, so do we have is this okay before I proceed to the next part? Is that okay? Okay, let's see if there's space here. Okay, I can use just this. So just to mention it again so that you see the difference, If you have got, let's say, so we are talking about the random sampling, which we can divide into with replacement and without replacement. I'm going to use the same example for these two. Let's say you have got four green balls and then six, let's say, blue balls. Okay, so if we're dealing with the first scenario, what will be the probability without replacement? So for the first pick, we can either pick a green ball or a blue ball. If you pick a green ball, the probability of picking green in the first pick, remember the green ones are 4, so it will be 4 out of 10. Probability of picking something that is blue is 6 out of 10. And then you can also have the second pick. Let's say you picked the balls twice, right? You picked the first one with replacement. You replaced it. And then you went and picked the second one. So when you pick the second one, you can either pick a green one again or a blue one. Again, same here. You can either pick a green one or a blue one. But remember, it's with replacement. So at the beginning, we picked a green one, but we replaced it. So the green ones are still 4, and the total is still 10. So the probability of picking another green one will be still 4 out of 10. And then here, the probability of picking a blue one, the blue ones are still 6 out of 10. So if they said find the that would be the same way down here. It will still, the green one will still be 4 out of 10, and then the blue ones will still be 6 out of 10. So if the question was saying find the probability of picking two blue balls. So two blue balls, it's B, B. So we're going to get 6 out of 10 times 6 out of 10. That will be the probability of picking two blue balls. If they said find the probability of picking balls of different colors means green with blue or blue with a green. So what we're going to do is we're going to get 4 out of 10 times 6 out of 10 plus 6 out of 10 times 4 out of 10. Those are two different colors. But if they said find the probability of picking a green ball and then a blue ball. So you are going to get a 4 out of 10 for green and then multiply by 6 out of 10 for blue. If they said find the probability of picking balls of the same color, you get G, G that same color, and then B, B that same color. So G, G you get 4 out of 10 times 4 out of 10 plus B, B you get 6 out of 10 times 6 out of 10. Okay, so that is how you work out if they told you it is with replacement. But if there was no replacement, what is going to happen is that in the first pick, if you pick something that is green or something blue, if you pick something that is green, it will be 4 out of 10. If it is blue, it's 6 out of 10. But remember, you've not replaced the ball. So for the one on top, we picked something that is green. So again, if we pick a second green ball, the green balls are no longer 4, they are now 3. The total has now reduced, it's now 9 because we removed one. But the blue ones are still 6. The only thing that has changed is the total, which is now 9. For the second one here, since we had picked a blue one, so it means that it's the blue ones that have reduced. They are no longer 6, so now they are 5. The total is now 9. But the green ones have not changed from the 4 that we had at the beginning, so they are still 4, but the total is 9. The thing is that when you add these to 4 out of 5 with 5 out of 9, it should give you 9 out of 9. So if they ask you to find the probability that you've picked two balls of different colors, you are going to get G, B, and then B, G. So 4 out of 10 times 6 out of 9 plus 6 out of 10 plus 4 out of 9. If they said probability of finding, getting balls of the same color, you get GG plus BB. GG is 4 out of 10 times 3 out of 9 plus 6 out of 10 times 5 out of 9. That is how you work them out. If they said find the probability of picking two green balls, it is GG just. So it will just be 4 out of 10 times 3 out of 9. Does that make sense now? Excellent. Thank you so much. So when you are measuring your values, you have got what we call the measures of dispersion and the measures of central tendency. So you have to know them. You need to know what how we use them. Okay. Very soon we'll be concluding. So if we start with the measures of central tendency, central tendency is what things measure values that are found on the middle. So it depends with whether the data you're talking about is qualitative or is quantitative. For qualitative, the measures of central tendency have got nominal and ordinal. We talked about them. For for nominal values, these are values that have got no ranking. For example, color. Okay. For example, blood group. You can't say, okay, this one is big, small. No. So there, for things that don't have a ranking, you use mode as a measure of central tendency. You are going to look at what is appearing the most. For example, you have got six people that are dark, two people that are, let's say, white. So the mode here is going to be 6, the one that is appearing with the highest frequency. So in this case, it's the black, right?